Hi everyone, welcome to the sixth episode of the tutorials on Nextflow for Bioinformatics. In today's video, I'm going to show you how to write a Nextflow script to perform genome mapping with BWA. And let me say that the Nextflow script for this tutorial is available, so if you want it, check the description box, the download link to the file is there. If you also want a one-on-one tutorial with me on Nextflow, you can always contact me. My email address is in the description box. Now for this tutorial, you need to make sure that you have Nextflow installed. You should also have BWA, and you should also have samtools installed. I have tutorials that show how to install each of these tools. So check the description box, you'll find the links to those videos. So use those videos to set up your PC. Now let's open the terminal and start the exercise. Okay, we are in the terminal now. So what I'm going to do next is to create a working directory and then I'll cd into it. So I'll say make the Nextflow and then I'll cd into it. So that will be cd Nextflow. So it's done. You can give it any name also. Maybe you have a directory called Nextflow already existing on your PC, so you can cd into it, create another directory. You can name it as mapping and then work in it. It's fine. It helps you to keep your files organized, and it can also help to prevent maybe the accidental deletion of files. So it's always important to have separate directories for different projects. So that's why you always see me creating directories for my projects, or let's say for the tutorials basically. All right, so let's proceed. So we have cd into it. What's next? What we are going to do next is to download the example data. We will need FASTQ files, that's the raw reads. We will also need the reference sequence. All right, so we are going to start with the FASTQ files, that's the reads. So let's visit the ENA database. There's a page, and I'll leave the link to this page in the description box. So when you are here, come to this side here, the accession ID here, this entry box here, and then paste this accession ID. I have left this in the description box, so use that to also do same. So when you paste, come to view, click on view, and then you'll be sent to this page. Now this page also, I have the link, so I'll leave the link in the description box. So you don't need to even do the search. You can just come to this page directly. So that's it. So these are sequence read for a Mycobacterium ostrans isolate. I like using this detailer because the file sizes are very small, so the normal PC can handle it. So we have paired end reads that we will use. So we will use these ones here. And by the way, this particular project, they generated Illumina reads and they also generated long reads. So I am using the Illumina reads for now. So those are paired end reads. So we have read 1, read 2. So I'll download them first. So to download, I'll just right click and copy the link, and then I'll move the terminal and then download it. All right, so that's it. So I'll use wget to download it. So I'll paste the link and then I'll execute this command. So this will download the read 1 for me. Okay, so we have downloaded the read 1. Let's do an ls. We'll find the file there. Now let's clear the screen. Let's do an ls one more time, and then let's download the read 2. So we'll go again to the page, and this time we will right click the read 2 and copy the link. We come to the terminal, we type wget or wget, you paste your link, you execute the command, then the file will be downloaded for you. So let's get them downloaded. Okay, so the file has been downloaded. So now we have both files. Let's do an ls. You'll find both files there. Let's clear the screen. Let's do an ls one more time. So I am going to put these files in another directory. So I'll say make the FASTQ, and then I'll move them there. So that will be mv star.fastq.gz. And then what do? I'll specify a directory. So that will be FASTQ. So I have moved them there. So do an ls, you find your FASTQ directory, do an ls into it, you find your files there, the reads. So that's how we do it. Now let's also download the reference sequence. So we need the reference sequence for Mycobacterium ostrans. So let's get that also. So this is the page where you can get the FASTA file. I'll leave the link to this page also in the description box. So we have that here. So when you are here, I want you to come to this side here and then click on Send To, and then come to File, and then click on this one here. The format, click it and select FASTA. And then click on Create File. And then you can save it in the directory of your choice, but I'll save it in the same working directory. So here I'll create another directory called ref. And then I'm going to save it, but I'll also want to rename it. So instead of the word sequence, I'll say AGY99.FASTA. This is how I'm going to do it. So I'm going to save it this way. So this will be the name for the file, the FASTA file, the reference sequence. So we have that done. All right. So that's it. So I'll go back to the terminal and then continue. So because I have created another directory, when I do an ls, I'm going to find ref. When I do an ls into ref, I'm going to find the reference sequence there. So that is it. So now we have the files there. So we have our FASTA files, the reads. We also have our reference sequence. So we can proceed. Okay. So what we are going to do next is to index the reference sequence. We need to index it. So I'll say BWA index, and then I'll specify the file. So that'll be ref/AGY99.FASTA. So I'm going to index it now. So let's execute the command. So this will not take much time because it's a small file. All right, so it's done. So let's clear the screen. Let's do an ls into ref. We are going to find some additional files there. All right. Now, ideally, we should have included the command, this one here, in the Nextflow script, but the focus of this tutorial is to show you how to perform the mapping itself. Okay, how to write a script for the mapping. So that is why I did not include this in the Nextflow script. But by the way, I have a separate tutorial that also shows how to write a Nextflow script to index your reference sequence. So if you really want to add that, you can check the description box. The link to that video is there. So that's it. Now let's proceed. Now let's do an ls into our FASTA directory. Yeah. So we are going to perform the mapping, but what you should also notice is that if you have your liminal reads, your raw reads, ideally you should perform quality control. Right? So quality control will help you to identify possible issues and you can resolve them. And so when you resolve them, that means you would have gotten rid of low quality reads, and that will save you time when you are analyzing the data. But for this tutorial, again, the focus is to show you the mapping, so I will not do any quality control here, right? Quality control, I've covered one tutorial also, so if you are interested, check the description box, the link to that video there. So in that video, I showed how to write an Nextflow script to perform quality control using FastQC. All right, so quality control involves assessing the quality, and it also involves trimming. So you can trim adapters. You can also filter reads. Maybe you may want to remove reads that have an average quality of this threshold. So you can use tools, other tools to do that. But those things, they are subject for another day. All right, so I'll make another tutorial for that also. But for now, let's focus on getting the script for mapping our reads. That's what we want to do now. Okay, so before we write the script for the mapping, let's take a note of some things. First of all, let's take a note of our working directory. So I'll do a pwd. So I need this information. And then I also need the path to the index files. This one here. So that means I need a path to the directory, which is this one here. If I do an ls, I see my ref directory, but I need a path to this one. So I can use ref path ref to get it. So that will give me that information. So I need this one. And I also need the file name for the reference sequence, which is this one. All right, so this one, I don't need a full path. I need just that file. We'll combine this with this in the script. So I need that information. And I also need the directory, which are the FASTA files, which is this one here. All right, so that's this one here. Again, you can use ref path to get it. All right, so I need that information. So ref path works in Linux system, but for macOS, I'm not really sure. I tried once, it didn't work for me. So I'm not really sure if you can use that rel path to get a path, but you can still do a cd into the directory of your choice and then do a pwd and you'll get a path. All right, so that one, you should be fine with that, so no worries. So I need all that information, all those information that I have specified. We will input them later on. All right, so now let's open a file and then put in our Nextflow script. I like using Nano, that's what I'll use, but you can use any other text editor, that's fine. So I'll say Nano and I'll say pipeline.nf. Again, you can use any name of your choice, it's fine, it's up to you. All right, but I prefer to use this name here. So I'll open it and then I'll start. Okay, so we have opened the terminal, so I'm going to start. So I will start by specifying the directory which has the index files. All right, let me just open another terminal here. So the index files can be found in ref. All right, so I want the path to ref, which I earlier on specified, or I earlier on showed how to get it. So I'll just do it again. So that'll be rel path ref. So I need this information. All right, so in the Nextflow script, I'll say params.index_dar equals, I bring my double quotes, and then I will just copy and paste. I don't want to type now, I'll just do a copy and paste, but you can also type just to get a feel of the command line. So I need this information. That is number one. Number two, I need the file name for the first A file. All right, the reference sequence redundant, the first A file. Let's just check it here. So that is this one here. I need just the name. All right, so I don't need a path for this, just the name is fine. So that'll be params.ref equals, I bring my quotes and I'll just paste the name here. All right, so that is it. So I'll combine this and this later on, but for now, just follow my lead. The next line, you will also specify the FASTQ files, the reads. All right, now let's do something here. I'll say ls, you know, the reads can be found here, or FASTQ files. All right, so if I say ls FASTQ / *_, I bring a curly bracket, I say r1 r2 curly bracket close, and I say star. If I execute that command, I'll get this and this. All right, so this command, I'm going to use a slightly modified one. So that is what we use to get the FASTQ files. Now we are dealing with paired and reads, so that is why this command is also very important. All right, it also helps us in situations where we are dealing with multiple paired and data. So this command here will save us a lot of trouble. All right, so we are going to use a modified version in the Nextflow script. So here I'll say params.FASTQ. In some tutorials, you also see them type reads. That's also fine, but I prefer to use FASTQ. Equals, and I bring my double quotes and I'll say /home/obuna/nextflow /FASTQ *_ curly brackets r1 r2 curly bracket closed, and then I bring star again and I bring my double quotes. So this completes that command. We will also use this information, it's very important. All right, now let's proceed. So now we have everything we need for now. So we have to define our process. So the process is the task. We are going to perform mapping, so we need to define that. So that one, I'll start here. So I'll say process, and I'll say map. You can use any name of your choice, that's also fine. It's up to you. So I define my process, I give a name, I bring my curly brackets, and then another line, I bring my closing curly brackets, which is supposed to be like this. Let me just type it here. Like this. Okay, so always curly bracket starts and ends for the process. And then in between, you can specify your information. Now with the information, we will start with our inputs. I'll bring my colon. The next line, I'll supply my input. So with the input, I'll supply 3 inputs to the process map. So I'll define them here. So the first one, space, I'll say path, and I'll say index_dar. This represents the index directory. It's a placeholder. The next line, I'll say val, which is value space, and I'll say ref. This represents this name here. And then the next line, I'll say tuple. I will explain this later on. So I'll say tuple, and I'll say val into brackets sample ID, comma, and I'll say path into brackets _kill. All right. Now I'm using tuple because with this command here, in addition to the files here, Nextflow also makes available the sample name, which will be this one here, So if you're using your classical command line for mapping and you have multiple samples, then in addition to you getting both files, you also need to issue a command to get the sample name. So you can use utilities like base name, set or cut, etc. But Nextflow makes this name available for you. All right, so we have our pattern. All right, so this. All right, so everything before this Nextflow tells us is a sample name. All right, so that's why we have this here. So this is what will be given to us. All right, so we have our paired end data, and then this becomes our sample name. So in the Nextflow script, I set sample ID. All right, so don't get confused. So sample ID, sample name, it refers to the same thing here in the context of this tutorial. So take note of that. So that's why we have specified this, and I'll link them up later on. So this is it. Now let's move to the next line. We will supply the outputs. So output colon, now say space path, double quote, star, double quotes. Then the next line, scripts. This is where we place in our command. So scripts colon, and then the next line, 3 double quotes, another 3 double quotes. And then in between, we will place our BWA command. So for the mapping, we are going to use BWA. So I will say BWA mem, and then I'll have to specify the reference sequence. All right. So I'll say $, I bring my curly brackets, I'll say index_dar. That's this. I close it and I'll say /$ again, curly brackets, I'll say ref. All right, so that is for the reference sequence. Space, and then we supply BWMN with our paired end data. So we have read 1, read 2. So we say $Pascal. Or you can also bring your curly brackets and say $Pascal. That also works. All right. So here you realize that we don't need to specify the R1, R2. We just have to indicate $Pascal because this here is a placeholder for our read 1, read 2. If we were to use the normal command line, then we have to supply read 1, read 2, but we don't need to do that in Nextflow. Nextflow makes it available for us, okay, through this command and another command that we are going to issue. All right, so this is for the BWA mem command. Now with this command, it will generate a SAM file, but ideally, what you should do is to convert the SAM file to a BAM file because BAM files have a smaller size. So I'll add another thing here. So I'll add my pipe, and I'll say samtools view. I'll say -h -b. I'll say -o. And I'll say curly bracket sample ID .bam space, and I'll say dash. All right, don't forget to bring the dash. It's also important. So the dash here simply means that the outputs for this command should serve as input for this command, the samtools command. All right, so samtools will convert the information to a BAM file, which will save There's the sample name here. So that's it. All right. So with the sample ID, yeah, I keep on messing them out. It's the same thing, by the way. So the sample ID or sample name, if you want to call it that way. So the sample ID, we already specified it here. All right. Remember, I told you that if you're using your normal command line for the mapping, you also have to issue some command to get a sample ID, but Nextflow automatically makes it available for us. So we don't need to do any work again. So that's why we have it this way. All right. So this makes it very easy, especially in situations where you have multiple samples, multiple paired end data. So you don't need to do much. Just use the command here and then all the samples will be mapped. That's all that you need to do here. So we are done with this command. So let's proceed. So let's close this and then proceed. So we are done with the process. All right. So that's it. So let's continue. So after defining our process, which is map, we need to call it. But before we call it, we also need to create channels, and in these channels, we'll supply the process map here with the information. So the information here, I'm referring to the inputs here. We have 3 inputs. All right, so everything will be done here. So we will start by saying workflow. I bring my curly brackets and then another curly brackets, and then in between I'll specify them. So I'll start with the first one, which is the index dash. So I'll say index underscore ch equals, and I'll say channel dot from path, and I'll say param dot index underscore da. The next channel is going to be the ref. That's a reference sequence. So I'll say ref underscore ch equals, and I'll say channel dot off. I bring my brackets. I'll say parent dot ref. And then the next line here, let me just put a space here. The next line will indicate a channel for the FASTQ file. So I'll say FASTQ underscore ch equals, and I'll say channel dots from file pairs, because we are dealing with paired entries, so we want them in pairs. And then I'll say params dot FASTQ. Then I'll close it. Let's just make sure that we have specified the correct names. All right, so everything is fine. So we can proceed. So after doing this, we can now call the process map and then supply the information. All right, so here I'll say map into brackets. I'll say index underscore ch, comma, ref underscore ch, comma, FASTQ underscore ch. All right, so they should be in the same order as you define them here. It's important. All right, so that is it. After that, we also want Nextflow to display the output for us. So I'll say map.out.view. That is it. So now let's save changes and exit first. So Control X, and then I'll save the changes. So that will be yes. All right, so that is done. So now we can execute Nextflow. All right, so let's do this. So let's call Nextflow and then supply it with our file. That's pipeline.nf. But you can still do an ls to check the file. Let's do it first to see our file, then we can proceed. So I'll say Nextflow run pipeline.nf. So let's execute this command. Okay, Nextflow is now working. But then let's take a look at what's happening. So we see this here. It says 1, process with name map overrides a built-in operator with the same name. So that means there is an operator with the same name as map. So that means that we shouldn't use the word map. It's not a good idea to use map as the name for our process. So what I'm going to do next is to just cancel this and then rename the process again. So I'll just use Ctrl C to cancel like this. I'll clear the screen And then I'll do a nano again. Pipeline. Let me just do it here again. So nano pipeline.nf. And then when I come here, I'm going to change the name. So I'll just say mapping. All right, to change the name. All right, so I don't want to have any conflicts. So I'll also scroll down again here. And when I come here, I'll change it to mapping. Now when I come down here I'll change it to mapping. All right, so this one should be okay. We are not going to see the warning again. All right, so I just want to also bring to your attention. So I just wanted to bring this to your attention. Sometimes you may have that warning. So if you do that, the best way is to just make the changes. All right, so after making the changes, I'll just type Control X, Y. I'll save the change. I just check the stuffs here. And then when you do that, you realize that you have a directory called work. All right, so I'll remove it. And then I'm going to rerun Nextflow again. All right, so I'll do this. So I'll say Nextflow run, and I'll specify my pipeline like this. And I'll execute the command. All right, so hopefully this one is going to work because there are no conflicts with the names. So everything has been done. So this one is going to take us about 7 minutes or so. I tried earlier on, so it took me about 7 minutes. So let's wait for everything to get done first and we can proceed with the next activity. Okay, the Nextflow pipeline has been executed successfully for us. So you will see this information here telling you where the output file is. All right, so it's here. So this output file here is in the Nextflow work directory. It's a directory that Nextflow will always create and then place in the output file. So it's the default setting for Nextflow. If you do an ls, you'll find it again there. You know, we removed it, but you will still find it because we have run another Nextflow script. So we have it there. So if you do an ls, you are going to find a directory and you can ls into it, and then you find others, and then you can also check. All right, but this can be cumbersome. So what you can do is to specify a directory where Nextflow should save the output files. All right, so that's something we are going to look at next. You know, with our Nextflow scripts, let me just open it here. We just wrote our scripts, but we did not specify any directory where the output should be saved. And that is why Nextflow placed it in its default directory. That's the work/this and this. All right. So we are going to modify the scripts, and this time we are going to specify an output directory in it. So the output directory, we don't need to create it ourselves. Nextflow will create it and then save the output in that directory. So let's modify the scripts again. I will clear the screen, do an ls just to check stuffs, and then I'll open the scripts again. So do same. All right, so we are going to add that information here first. We will define it here. Let me just add it here. So I'll say params dot, you can use any of your choice. All right, so I'll say bam underscore da equals, and I bring my quotes and I'll say /home /Kobana Nextflow / and I'll say bam like this. So this is going to be my output directory. Now when I come into the mapping process, just here before the inputs line here, I'll specify another command. So I'll say publish dir like this. I bring a bracket, I bring a double quote, I'll say $, I'll bring a curly brackets, and I'll say params.bam underscore da. I'll close the curly brackets, I add another double quotes, and then I'll bring a comma, space, and I'll say mode. I bring a colon, space, and I'll say single quotes copy. And I bring my brackets again, the last one here. So this here, what will happen is that Nextflow will create this directory, and then the output will be saved in that directory. All right. So here I'm using mode because I want a copy of the output to be saved in that directory. You can use other modes such as move and start, but I always recommend you use copy. And then when you are done, finally, you can remove the entire Nextflow working directory, or let me just say the work directory, all right, the default directory where the output files are saved, all right. So always use the copy until you are done. But the decision is yours. You can use move or any other modes, that's fine. Just check the Nextflow tutorial page, you'll find information about this one here, all right. So that's it. So we don't need to do anything else. That is it. So we will just exit and then save changes, and then we are going to rerun Nextflow again. All right, we can still remove it -fr. I prefer to remove it, but you don't need to do that anyway. I remove the work directory, and then I'll rerun Nextflow. So I'll say Nextflow run pipeline. So let's execute this command. All right, so it's been done. So it will also take about 7, 8, 9 minutes. So let's wait for everything to get done for us. It might even be faster depending on your computing power. So let's wait for the activity to get done. Okay, the mapping activity has been completed. So you will still see this coming up. All right, so indicating that the BAM file has been saved in the default directory, which is work, but a copy has been made available in the directory specified. So if you do an ls, you are going to find the directory specified. I use BAM. So if I do an ls into it, let's say ls BAM, I'm going to find a file there. All right, so that's what you need to know. Now let's take a look at something here. I'll just do an ls again. Now with the BWA command we use, let me use this command to get it. I'll say grep. I'll just do BWA like this, and I'll say pipeline. I just want to get that line. All right. Now with the BWA command we use, it's possible to include the number of threads. All right. If you're using a Linux cluster, if you're using an HPC system where you have access to lots of cores, you can specify that here, and then that will make BWA run faster for you. All right. So I've already shown how to do that in some tutorials. I will leave those tutorials in the description box. You can also specify the read group. Some tools like GATK require the read group information. So if you don't specify it, it's likely it will not work. All right. So you have to also specify that. I have tutorials that show how to specify that as well. So check the description box. You'll find the link to those videos. You can also contact me, and then we can arrange a session so that I'll show you how to also include that information. All right. So that's what you need to know. Now, after mapping, there are things that you can do. Let's look at this slide. I think it will be helpful for some of you. So with the post mapping, I have a list here. This list is non-exhaustive, by the way. There are other things you can do. All right. And I have tutorials on all these activities. So check the description box. You'll find the link to those videos. One of the things you can do after mapping your risk is to get a mapping statistics. So you can use tools like samtools to do that. And if you have multiple samples, you can aggregate all the reports using MultiQC. All right. You can also index the BAM file. Some programs require the BAM files themselves as well as the index files. So you can use tools like samtools to index the BAM files. You can also visualize the alignment records. So you can use tools like IGV, Jbrowse, etc. All right. So visualization can help you to confirm, for example, if the variants you saw or the variants that you discovered were indeed variants. So you can check the alignment records to get that information. You can also filter the alignment records. So you can filter based on criteria like mapping quality. And if you're dealing with paired end reads, you can decide to select alignment records where the reads, both forward and reverse, map to the reference sequence. Okay, you can also do that. So you can use some tools to do that. And you can also use BAM tools for the filtering. You can also perform variant calling. You can use tools like GATK, FreeBias, BCF, etc. And I have tutorials on that, by the way. So check the description box. You'll find a link to those videos. So now that you are done with the mapping, you can also check this playlist here. It has tutorials on how to perform variant calling. And if you also want to support this channel, you can buy me a coffee. So you can use the link that is in the description box to buy me a coffee. So I'll see you in the next session.